Hello everyone, we're looking at example 10, which is also on page 525 of your textbook. We are now given the graph. We're given the graph, a picture of the graph, and we have to determine what the equation of that function is. Okay, so the first thing we want to think about is it a cosine or sine function? In other words, is it a wave? Yes, it is. Okay, so it's either a cosine function or a sine function. So sine or cosine. Now, does it look more closely like a sine function, or does it look more closely like a cosine function? Okay, and it's a little hard to tell from my diagram here. It actually goes through the origin. Okay, so that gives us a clue that it will be easier to say what this function is as a sine function rather than a cosine function, because remember, a sine function actually goes through the origin, where a cosine function, without any transformations that is, cosine function does not go through the origin, it goes through the maximum point at the y-axis without any transformations. Okay, so right off the bat I'll choose a sine function to represent this. Okay, so here is y equals a sine b x minus c plus d. That's transformational form of a sine function, and we have to figure out all the parts of this. Okay, so A. The question actually said write down the period and the amplitude, and that's a great starting point. Okay, so let's find the period of this function. Okay, so period means how long before, what horizontal length does it take before this function starts repeating itself. Okay, so if I start here at the origin and I trace along the graph, it's not repeating itself yet, even though it's going through the principal axis again, because it's going down now. If I come up here, now it's going to start repeating itself. All right, so this distance is the period, and that distance is, I need to figure out that distance. Okay, it's kind of hard to tell for sure that distance here based on the scale that was used for this graph. So let's take another look at another clue. How long before the next period happens? Okay, so there's another period. Again, it's hard to tell exactly what that x value is. So let's go for another one. And this one goes through 2 pi. Okay, so we have 3 periods in the space of 2 pi. 3 periods in the space of 2 pi. So that tells us, there's another period. So that tells us that in the space of 2 pi, we have 3 periods. So 2 pi is divided into 3 periods. So the period must be 2 pi over 3. Okay, let's talk about that again, make sure it makes sense. We need to figure out how big the period is. We need to figure out how big each of these are. And it's not exactly obvious based on the scale of the x scale on this graph. So go to look at the next and the next until how many periods we can tell is at a x value that we can definitely say is an x value. That x value is 2 pi, and we have 3 periods in that length of 2 pi, which means each of these must be 2 pi over 3 units long. Okay, so the period is 2 pi over 3. Now we have to figure out what does b equal. And remember, b is based on period equals 2 pi over b. So now we know what the period is, so we can substitute 2 pi over 3 into this equation. 2 pi over 3 is equal to 2 pi over b, and then solve for b. You can see here in this case, because the numerators are equated, that the denominators must be equal as well, so b must be 3. Or you could do it algebraically. 2 pi b equals 2 pi times 3. Okay, multiplying both sides by 3 and both sides by b. And now divide both sides by 2 pi. And b equals 3. Okay, so b equals 3. We know there's a 3 there now. All right, we need to figure out a as well, the amplitude. Now remember, the amplitude is from the principal axis. We can see the principal axis. Let's be sure where the principal axis is. the principal axis is in the middle of the maximum and the minimum. So here's the maximum, which is 0.5. The minimum is down here at negative 0.5, which tells us then that the middle of that will be 0. So the principal axis will be D. Okay, so that's another good hint. D is going to be 0. Okay. All right, so therefore the maximum from the principal axis to the maximum is this distance, and that distance is 0.5. Okay, so amplitude is 0.5, and A will be the D value, or the maximum value, subtract the D value. Okay? So in this case, the amplitude, because D is 0, the amplitude and A are the same number as each other, so 0.5. All right, do we have any horizontal translation? No, we do not, because it goes through the origin, and y equals sine x also goes through the origin, so we do not have a horizontal translation either. So this equation is y equals 0.5 sine 3x. And there you have the answer. Now, could we have said that this is a cosine function and figured out what that is? Yes, we could. All right, so let's do that as well. If we had decided this was a cosine function instead, what parts remain the same and what parts change? Okay, so if we had said this is a cosine function, I'm going to represent this graph as a cosine function. Excuse me. Okay, the amplitude will stay the same, so that's still 0.5. The period stays the same, so therefore B remains the same at 3. The principal axis remains the same, so that is still 0. The horizontal translation is what is different between the sine function and a cosine function. Now remember, we said that on a cosine function, the maximum goes through the y-axis. Okay, so if we know where this maximum is, then we know that this distance is the horizontal translation. So can we figure out what that is? Well, we know that the period is 2 pi over 3. So we know from here to here is 2 pi over 3. And we know that the middle of 2 pi over 3 would be where it crosses the principal axis. So divide that by 2. So this distance would be 2 pi over 6, okay, or pi over 3, which is half of 2 pi over 3. And then between the principal axis and the maximum is also half of pi over 3. So this distance here would be pi over 6. All right, and it's moving to the right. Okay, so C is pi over 6. So this same graph could be represented as a cosine function like this. 0.5 cosine 3 x subtract pi over 6. Okay, so both of those answers are actually correct. But this one is more simple, which if you take a look right off the bat, is it better to represent this as a sine function or a cosine function? Well, the sine function answer is clearly more simple, so the sine answer would be a better answer. Okay, have fun.